Another sign that you've got a chemical reaction is if a solid forms from solution. Now I have two solutions here that, if you look at them, are colorless, not colorless, this one's got a little bit of yellow to it, are clear. You can see through them. And so I've got these two clear solutions. And when a solid forms from solution, it's not like a rock that falls to the bottom of the test tube, but it'll get cloudy, and that is an indication that there's very finely divided particles suspended within the liquid. So as I dump these together, this is just a solution of lead nitrate and some potassium iodide, but we see that it gets cloudy. You cannot see through this test tube anymore. And as it sits, it will settle out, and maybe we'll look at that again a little bit later, and you can actually see that it has settled to the bottom. But anytime you add solutions together and you get that cloudy look to it, you know that a chemical reaction has taken place if there wasn't anything, if they were clear to begin with. Another indication that a chemical reaction takes place is if substances are added together and gas bubbles form. So if you form a gas in solution, then that is an indication of a chemical reaction. I have some hydrogen peroxide that I'm going to put into this beaker. And, sorry, that's not a beaker, that's a graduated cylinder, but I'm going to put it in this graduated cylinder, and I want to add a few other things to it. One of the things I'm going to add is some soap. Now, the only reason I add this soap is because as the bubbles form, the soap will capture those bubbles and we'll get a nice foaming effect. I'm going to add a little bit of food coloring. Now, we call this demonstration elephant toothpaste, making elephant toothpaste. It's not really toothpaste, but we'll see why it's called that here in just a second. All right, I'm going to mix those together. Now, hydrogen peroxide will naturally degrade and give you oxygen gas. But what I'm going to do is make this reaction take place much more rapidly by adding a catalyst. Now, this catalyst is just some potassium iodide, and I'm going to dump this into there, and then we'll see the reaction rapidly taking place, and we'll see the formation of our elephant toothpaste. Okay, so bubbles are forming, bubbles of oxygen gas are forming, and the soap is just capturing those bubbles. And when the circus comes to town, I take care of the teeth of all the elephants. The next indication that a chemical reaction has taken place is if the substances change color. So if you add substances together and they change color, now this is not like making, putting blue and red together and making purple, but this is adding things that you just don't expect that color at all. I'm going to put this on here. It's got a little light so that we can see the nice colors. And I'm starting with some nickel sulfate. And nickel sulfate is just a green color. And what I am going to do is add various other substances that right now basically the nickel ions are surrounded by water molecules because it's in solution. And I'm going to surround those nickel ions with different what we call ligands. The first one I'm going to add is ammonia, and we're going to know that something is really happening when we see a color change take place. So, first color change, nice pretty blue there. Okay, the next one I'm going to add is ethylene diamine. And we see that pretty purple. This is where chemistry looks like chemistry. You have nice color changes. And then the last one, gloxine. And in this one, we can see it gets red, but we can also see one other indication, even if the color didn't change, an indication of a chemical reaction because we can see that it's gotten cloudy. And we have again formed a precipitate, a solid coming out of solution, so that is an additional example that a reaction took place. When these substances are added together, will produce light. So that's an indication of a chemical reaction. There's no flame. We often associate, if there's a flame with a chemical reaction, that obviously produces light. This one doesn't get hot. You'll have to take my word for that. Doesn't get hot, but it does produce a pretty blue light. So we're going to turn the lights out, and you're going to be able to see the color spiral through this funnel. Oh, a little bit more because that's just so much fun. Okay, so we definitely see the blue color. As those reactants do their reaction, we see a blue color. Now this is something we can see in fireflies at night. There's a chemical reaction that takes place in their bodies that produces light, sort of like that. And you experience those with glow sticks, maybe that you've bought at a carnival or at the zoo or someplace like that. Okay, now we're going to, inside of this flower pot is a mixture of powdered aluminum. So imagine aluminum foil ground up into a little powder, and iron oxide, which is basically rust. And so they're just in powder form. This reaction will take place, and it's a pretty intense reaction, and it gives off a lot of heat. It produces so much heat that what will pour out of the bottom of this flower pot is molten iron. And so I've got a sand bucket here to catch that molten iron. But I don't want to be close to it when it happens, so I've got a fuse, an igniter, something to get it started, and that's these two ingredients. So this is just a little side reaction to give it enough heat to light it, kind of like you light a Bunsen burner with a match. Well, this I'm going to light with this just a delay mechanism, okay? You're going to know that the reaction is taking place because before it happens, it starts smoking and sizzling, and then it'll ignite. Okay, so this is a little potassium permanganate, and this is a little glycerol that I'm going to pour on top. That's going to give me my delay. So I can back up. This is usually where I have my class sing the Jeopardy theme song, something to pass the time. Here you go. See it pour out of the bottom there? That was the molten iron. I'll go over here in just a second and I'll pick it up so that you can see the glowing iron. Okay, so that was the iron that was produced in the reaction, and it's so hot that it's still glowing red. That's called the thermite reaction.